This is the EDS82B, also known as the LeakSeeker 82B, and this is the high definition version. This model has been made since 2004 to the current day. What we're going to do today is just show you the basic functions of LeakSeeker and the basic idea of how it works. And after this video, there are 4 other videos showing the various methods that we'll be showing you to use, such as the 2-wire method, the 3-wire method, the hot air method, and the 4-layer method. So right now we're going to introduce LeakSeeker. This is a power switch, which right now is off. In the down position is your normal 2-wire test position. In the up position is a 3-wire test position. And we're going to start off with the 2-wire first. Over here is a set of LEDs, and right now the red LEDs are showing that the resistance is higher than what the LeakSeeker is rated for, mainly because we're not touching anything. It's higher than 150 ohms, and the LeakSeeker can measure and can locate shorts anywhere from a dead short up to 150 ohms with a 20 micro-ohm precision. That would take about an 8 or 9 digit DVM in order to be able to do the same thing with a DVM and memorize each reading. So, in essence, what this is called a window. It's 9 LEDs, 3 red, yellow, and green LEDs. And the yellow LED at the very end is a wait light. That's when the LeakSeeker is calibrating to a new window. Each window represents 20 milliohms. These are 20 milliohm segments. There are many of these 20 milliohm segments, literally tens of thousands of them, in the area between 100 and 150 ohms. So what LeakSeeker will do in the automatic mode, as you can see we're in the automatic mode by the green LED here, is it's going to find the proper window the very first time we probe. Now, I'm going to show you this board here, and if you focus in on the board, you'll see that we have lands marked in a dark color here. The top color is like a blue color, and the bottom land you can see is marked by a red color, which probably looks black on the video. Now, we know there are shorts in this board, and we're going to prove that basically by, on our Fluke DVM over here, we're going to measure a pad anywhere along this top trace, and I'm just going to measure this pad over here, and you can see by the DVM it's about a 3.6 ohm short. Now, the point is that if we go pad hopping, I'm going to move a little further down over here, and for example, when I get on this pad, you'll see, if you look at the DVM, we're still showing the same short, as soon as I get a good connection. And we can come along anywhere along this. I'm going to come way down to the end of the board over here, and as you can see, same thing. We simply don't have the resolution in this Fluke meter in order to know where the short is. It's roughly going to be the same along that trace, because the resolution of the Fluke is only basically a tenth of an ohm. The LeakSeeker, of course, can go down to 20 microohms, so it's considerably more sensitive. So the way you use LeakSeeker is first you push the reset button, which shows that we're going to tell LeakSeeker to start looking for a new short. Again, it doesn't know what the range is. It's going to start at the very highest and work its way down. We're going to be locating a short somewhere along this blue trace, and we don't know where to start, so it doesn't matter where. I'm going to start here. So paying attention to what I'm doing here on both the board and on LeakSeeker, as I touch this pad, LeakSeeker is calibrating. See, the wait light is on. And when it finds a window, it's comfortable with a reading. Now, at this point, it is automatically gone to a particular 20 milliohm window showing those 9 LEDs. And if I start changing from pad to pad, for example, if I go in this direction, it just recalibrated, so I know I'm going in the right direction. Let me go back to where we were, and you can see there's no reading at all now, because of the fact it already calibrated to a new window in this direction. So we're going in this direction. We know the short is in this direction. So here's the next pad along here, and it's higher in pitch. So we're going the right way. Again, the older pad is a lower pitch. So we know it's in this direction. So let's go to this pad, and you can see that it went to the wait calibrate and changed to yet another window because it's getting even closer. And if we go back to the old pad, there's no reading at all. And that's because it's already calibrated to the new window. So we know we're going in the right direction. So let's go to the next pad. Now, wait a minute, it sounds like the pitch is getting lower. And here, the next pad, there's no pitch at all. So we know it's one of these two pads. And we know it's got to be this pad only because of the fact that's beeping the highest. And if we look on the other side of the board, you'll see that we have a diode that has a 3.3 ohm short. So this is the basic function of the LeakSeeker. It's basically to use the resistance of the PC board copper itself as a resistor and as a gauge. What happens is that this test probe is putting out a certain voltage and current that LeakSeeker is measuring, and each time you go to a pad, LeakSeeker memorizes that reading and compares it to the readings before and after. And this way, it's a comparison thing. You can adjust the offset if you want, and just to prove what it does, I'm just going to reset LeakSeeker and just start anywhere. And LeakSeeker right now, again, is going to find a window, and if you don't like that, you know, you can move it a little higher, a little lower, because maybe it went too close to the end, right? So maybe you want to adjust it. But you can see that for the most part, you really don't have to. LeakSeeker is pretty much going to do all the work for you. And the offset adjustment is more for the high resolution mode, which will come in one of the other videos that we'll see next. So this concludes the first video, which is the basic introduction of LeakSeeker 82B, the high definition version, and get ready to see the next video.